Modern AI agents read databases, move money, and execute tasks across enterprise systems at rapid machine speed. But this autonomy introduces a specific vulnerability. Nearly 40% of agentic AI projects are projected to be canceled by 2027 because organizations lack the necessary risk controls to manage them. The current reflex is to rely on observability tools, but observability just watches. It tells you exactly what went wrong after the damage is already done. If an agent leaks a customer's social security number, logging that failure in a dashboard doesn't help you. You don't need to observe the leak, you need to intercept it. Without a physical barrier standing in the path of the execution, these agents are operating entirely unguarded right when it matters most. This exact moment of risk is the trust boundary. It's the precise line where an agent's internal reasoning turns into a real-world consequence, like a message sent or a payment processed. Securing this perimeter requires a shift in architecture. AgentTrust sits directly on this output boundary, acting as an active inline gate that the agent must pass through. Integrating into major frameworks like LangChain or AutoGen requires a single line of code, a simple @harness decorator placed right above your agent's execution function. Once in place, AgentTrust evaluates and decides on every single execution in under 20 milliseconds. The output cannot leave until it clears the gate. Placing an active gate directly in the path of execution provides the mechanism to intercept errors in the milliseconds before they reach the real world. To see how a decision is made that fast, let's look at the flow of data. When an agent tries to release an output, that data packet sprints through 4 sequential engines. The first chamber is validation. Here, the system runs 9 deterministic checks, scanning the output for schema alignment, PII data leaks, and adversarial prompt injections. Next is the confidence engine. This analyzes the data to generate a weighted score, giving you an immediate estimate of how trustworthy the agent's proposed output actually is. The third chamber evaluates risk. It calculates the specific business impact and policy sensitivity of the action the agent wants to take. Finally, the decision engine takes all that preceding data and forces one of 4 strict outcomes: approve, retry, escalate, or block. Let's test it on a customer service agent handling refunds. The agent attempts to process a clean, fully compliant request. It hits the gate, passes the checks, and gets an immediate approval. Now let's break it. Leaks a social security number. Blocked. Hit with a prompt injection. Blocked. Payment missing a dollar amount. Blocked. In each case, the system flags the exact rule that was violated. Routing every execution through this pipeline ensures that every output is mathematically verified against enterprise policy before release. The financial implications of this governance gap are clear. Under the EU AI Act, non-compliance can trigger penalties reaching €35 million, or 7% of global revenue. AgentTrust solves this compliance deficit because it is deterministic by default. It doesn't rely on a secondary, unpredictable language model to enforce its core safety rules. It uses hard code, but it remains flexible. When you need deeper semantic checks, it's fully LLM upgradable. You can run it as an in-process embeddable gateway with 0 dependencies, or deploy it as a self-hosted edge gateway for central control. Every decision it makes is fully auditable. The system generates a tamper-evident cryptographic envelope for every single execution, fully compliant with ISO 42001 and SOC 2 standards. AI agents are powerful, but only if they are predictable. AgentTrust provides the necessary inline boundary, transforming autonomous systems into secure, audit-ready assets that scale safely across the enterprise.